Hello everyone, welcome to the next lecture on the numerical analysis. Today we will discuss about the Simpson one-third rule. I will explain this lecture with the help of the 12 examples so that you can learn it very well. Myself Dr. Harish Garg. You can simply follow my YouTube channel where there is a playlist of the numerical analysis. The last lecture was on the composite trapezoidal rule. Also, you can see the other lectures like Euler method, MATLAB code, modified Euler, Runge-Kutta, all are the part of your syllabus. And you can see the Newton forward, Newton divided, Lagrange interpolation is the part of your curriculum. Let's start with this video. So the Simpson one-third rule is used for finding, first of all, it's a numerical integration method, and it is used for finding the integration of fx over this domain a comma b. Now since we are using the approximate values by using the Simpson one-third rule, so what is the principle of this Simpson one-third rule? We can discretize this domain a to b into the finite number of these intervals like x0, x1, x2 and so on. If I consider y is my f of x corresponding to the value of the x0, we can obtain the value as a y0. Corresponding the value of the x1, we obtain the value of the y1 and so on. And the target is to integrate or target is to find the area under this curve by using Simpson one-third rule. Now remember, because this is the interval, so it has some length, say called as a h, it has some length called as say h2 and so on. If I consider that each has the equal interval, that is the length of this, length of this, length of this are same, then the method is called as Newton quadrature formula. And in this method there are several methods of the integration available. This method we already discussed in our last lecture, and in this method, in this lecture we will discuss about Simpson one-third rule. So as I told you, the Simpson one-third rule is a approximate form method which are used to calculate the definite integral. What is this method? We can join this node by using the quadratic curves, by using quadratic curve. Remember, if are using this, join this curve by the straight lines, if are joining these lines by the straight line, then the method is called as trapezoidal rule method, which is we discussed in our last lecture. However, if you join in the quadratic function like y is equal to ax square plus bx plus c, if it is of the quadratic nature, then what is the third derivative? 0. What is the fourth derivative? 0 and so on. So it means the degree of order 3 or greater than 3 becomes 0. Now if I, since each of the length is of equal intervals, if I consider this is my h, the length of the each interval is my h, how you can integrate from x0 to xn of fx? How you can do? I can separate this portion. Firstly, I can do like of first two portion like x0 and x2, and then we'll try to find this function. Fine. And then after that I can break this portion from x2 to x4, f of x dx and so on. Now the target of this is to find the values of this fx. How you find the value of the fx? Based on these 3 points. How you can find that? You can use either Lagrange interpolation formula, you can use either the Newton divided difference formula, fine, you can use either as a Newton forward difference formula, or you can use either as a Newton backward difference formula. So for the sake of simplicity, I can use the Newton forward difference formula. Here this is the del square, because the third derivative, fourth derivative and all are my 0. Now I can, now what is the y is, I can substitute this value of the y in this function, that is x0 to x0 f of x dx, where y is my fx. Now how you can integrate this portion? So since limit is my here, so I can find the value of x from this case. So what is that? What is the limit of the u? So I can find the value of the u is x minus x0 by h. So what is this integration? If x0 is my here, so it is my 0. What is the upper limit is? So upper limit is my x0 minus x naught divided by h. So this has the length h, this has the length h. So what is the difference between x2 minus x0? This is my 2h over h. So this is my 2. I can substitute this value, dx is my h of du, this h is my outside. Now we have to integrate with respect to u. So what is the integration of this y0 with respect to u? So y0 is a constant, so this is my 2 minus 0 of this, so it is my 2y0 plus what is the integration of this? Del y0 is outside, it's a u square over 2 from 0 to 2, it is my 2 del of this. In this case, del square y0 over 2 factorial is outside. What is the integration of the u square? U cube by 3 u square over 2 from 0 to 2. What is the answer of this? 8 over 3 minus 2 minus 0. So it is 6 minus 6. So 2 over 3 and divided by 2 factorial cancel out. It's a 1 over 3 del square y naught. Fine. Now I can substitute. What is the value of this? This is the first difference, that is y1 minus y naught. What is the second divided difference? It is y2 minus 2y1 plus y0. So I can substitute the value at here. You will get this expression. Now if I open this bracket, what will happen? This y0 will be cancelled, 2y1, and it will be minus 2 over 3 y1 plus y0 y2 plus y0 over 3. I can take 3 as LCM, and outside is a 6 minus 1 4 y1 plus y2 plus y0, or I can written as a y0 firstly and then c. So this is the integration of this curve. Similarly, I can find the integration from x2 to x4, that is by here. What is the replacement is? Instead of the y0, it is my y2. Instead of the y1 is a midpoint of this, and so on. And similarly, we can find it for the remaining parts. So if you add them, you can get here. Now by adding all these values, what is the left hand side is I1 plus I2 up to In. What is that? This is integration of x0 to xn fx dx. What will happen? H over 3 is common. This is the y0. There is only 1 times y0. 4y1, 4y3, 4y5, 4 times of this. So it's a y1 plus y3 and up to yn minus 1. It's a y2. It's a y2. It's a 2 times y2. y4, next term is y4, 2y4, and so on. So that's a 2 times of this part. So what this formula is called as composite, or called as the Simpson 1/3 rule, where h is my b minus a over n. Make sure if you consider n is my 2, then what will happen? This is only term is my, and this is called as simplex 1/3 rule. And this, whenever n is not equal to 2, then we call as the composite Simpson 1/3 rule. Make sure whenever you are using this, you have to take n is my even integer always. However, when you are working on this trapezoidal rule, as we discussed in our last lecture, n can be any value. But whenever you are working on the Simpson 1/3 rule, n must be the even integer. So whenever you are working on the Simpson 1/3 rule, n must be the even number of the subintervals. And this method is also called as the parabolic rule, because its a degree is my 2. How you solve this? How you solve this problem by using the Simpson 1/3 rule? It's a very simple. Whatever the function is there, you can simply take y is equal to fx, discretize this function as I explained you in my last lecture of the trapezoidal rule. We will apply the same rule here, but make sure n must be my even number. Fine. Once you can use here, I can apply this formula. How you can remember this formula? Remember, I can use this formula. It's a 2, 4, and here this is nothing but my even terms. and this is my odd terms. Remember students, if you watch my MATLAB code of this Simpson 1/3 rule, I have written wrongly. In that case is 2 times odd plus 4 times even. So you can correct in this lecture here. It's a 2 times even, 4 times odd. So I will explain you with the help of the 12 examples so that you can learn it simply. So look at this one. Find the value of this by using the Simpson 1/3 rule. Step size is 1/6. H is my 1/6. Fine. So which is given to be here. Fx is my here. Now firstly, we can find the value of the n. B minus A over H. Because they are talking about the Simpson 1/3 rule. Either it is my composite Simpson 1/3 rule or it is a simple one, but that's depending upon the n. If n is not equal to 2, then we can use the composite, otherwise here. So what is that? B is my 1, H is my here, so it is my 6, which is not 2. So it means we can apply the composite Simpson 1/3 rule. So what is that? I can make a table. What is that? Starting value is my A 0 and H is my 1/6. So 1/6, then 2/6, then 3/6 until you will get as 1. 4/6, 5/6 and last one is here. Now when x is 0, I can substitute this value. What is the value of this? It's a 1/1 plus 0 is my 1. When it is 1/6, it is 1/1 plus 36. So if you take the LCM, it's a 36/37. Similarly, if we substitute x is my 2/6 here, it's a 4/36. So that is a 36/40. You can write here and so on. So you can write into the 4 decimal places we can get. Now since n is my 6, so we can apply the composite Simpson rule, which is here 2 times even. How you can do? Remember, forget the first and the last term. Fine. And look at this. This is my y0, this is my y1, this is my y2, y3, y4, y5, y6. So look at that. This is my even, this is my even, and this is last term we already skipped that. So in this case, how many even are there? y2 and y4. What is the odd terms? y1, y3, y5. So these are my odd. Now what is the value of the h? Is a 1/6. Now what is the y0? That's the first term. What is the y2? y2 is my 0.9. y4 is my 0.6923 plus 4 times of this and so on. So once you can use this calculator, you can get the values as my here. That is the first part. Now the second part is you have to obtain the values of the pi. What is the integration of this? It is a tan inverse x over the 0 1. What is the tan inverse of 1? Pi/4 minus 0. So this is my here. I can substitute this value and you can find the value of pi is the right answer of this problem. Now look at the second example so that you can learn it more. So this function is here. What is my fx? Fx is 1 over here. What is the lower limit? It's a 2. Upper limit is 10. Again the Simpson 1/3 rule. Divide this interval into the 8 equal parts. It means n is my 8. So which is not equal to 2. We can use the composite Simpson 1/3 rule. Fine. Now we can here. What is the value of the h? Is b minus a over n. So n is my 8. What is the b minus 8 over? So h is my 1. So we can make a table. Start from the x. Y is equal to fx. So what is the value of starting value is my 2. Last value is my 10 with the step size 1. So it's a 2, 3, then 4, 5 up to 10. Now I can substitute this value of the fx. When x is equal to 2, it is 1 over 3. When x is equal to 3, it is 1 over 4. When x is equal to 4, it is 1 over 5 and so you can write into the 4 decimal places. Now this number is my y0, this number is my y1, y2, y3, y4, y5, y6, y7, y8. I can skip the first part and the last part, fine, and 2 times of this even number, fine, and 4 times of these odd numbers, 1, 3, 5 and 7. So you can see 1, 3, 5, 7 for the 4 times of these odd numbers and 2 times for the even numbers. I can substitute the value of the y2, that is the y2 is my here, y4 is my this, y6 is my this, and so on. If you substitute here, h is my 1, you will get the right answer as here. You can use your calculator so that you can get your answer in a very simple manner. Look at this another one. Now evaluate this by using the Simpson 1/3 rule. What is that? F of x is 1 plus x square, a is my 0, b is my 6, fine. Now what is the h? It is not given. What is the n? It is not given. So it's on you choice. Either you may take n is 2 or you may take n is not equal to 2, but always even number, fine. Remember, it is always a remember tips. When nothing is given to you, you always apply the composite Simpson rule. It's always preferred because you want to evaluate the integration. This method will always give you the better result because you have to discretize into the larger number. So you can choose any number, any even number. You may choose n is 4, you may choose n is 6. How you can choose? That is based on this formula. So what is the n? B minus a is this. So look at that. If I choose n is my 4, then what is my h? H will be my 1.5, fine. If I choose n is my 6, what is my h? H will be 1. So if you feel 1.5 makes some calculation difficult, then you may choose n is my 6, otherwise you may choose n is 4. So for the sake of simplicity, I divide this interval into the 6 equal parts, that is n is my 6. So what is that? Because it's an even number. So remember, we can't choose n is 5. 5 is not an even number. So what is the value of this is 1. Then rest of the part is similar. We can make a table, start from the lower limit with the difference here. I can substitute this value. When it's a 0, it's a 1. When x is 1, it is 1 over 2. When x is equal to 2, it is 1 over 5. When x is equal to 3, it's 1 plus 3 square. It's a 1 over 10 and so on. Now because n is my 6, which is not 2, so we can apply the composite Simpson rule. This is y1, y2, y3, y4, y5, y6. So this is my even number. I forget the first and the last part. First and last part, even number of this, odd 4 times odd of this. Substitute each value in this equation, you will get the answer as here. Look at this one. The trapezoidal rule of this gives the value 4. So when you integrate this, it gives the 4 by using the trapezoidal rule, and the Simpson rule will give you value as 2. Find the value of the midpoint. So what is that? Okay, first of all, this is given to you, x, y is equal to fx. Now look at that. Start from the 0, ending at the 2, and you targets to find this value. What is that? What is the step size is? 1. Fine. What is the n? B minus a over h. So what is that? B minus a over 1. It's a 2. So whenever n is 2, we have to apply the simple Simpson 1/3 rule. Fine. So now look at that. If you apply the trapezoidal rule, what is the trapezoidal rule is? H over 2. What is the trapezoidal rule? First term, last term. Fine. Now if you apply the Simpson 1/3 rule, now look at that. You have 0, 1, 2. The corresponding value is y0, y1, y2. Forget the first term and the last term, and since there is no even term, so it's only the odd term. Is a 4 times of this one. So I can find what is the h is. What is the h? H is my 1. Fine. So if I substitute here, what is my f0 plus f2? This is my 4. So h is my b minus a over here. H is my b minus a, because n is, for the trapezoidal rule, n is my 1. Fine. So this is here. So if I substitute here, h is my 2. So f0, sorry, this is for the Simpson rule, because for the trapezoidal rule, n is my 1. For the Simpson rule, n is my even number, n is my 2. So I can substitute here, we can get this value. I can substitute this value f0 plus f2 here. H is my 1 because n is my 2, even number. f0 plus f2, f0 is a 4 plus 4 times of 1 is my 2. So can you find the values of this? 4 times of f1 is 6. So what is the f1? 6 minus 4 over 4. So f1 is my 0.5 is the right answer of this problem. Look at this another one. You have to find the volume of the solid. So how you can find the volume of the solid? We all know this is the formula for the volume. I can return this is pi is outside, y square d into x. X and y are given to you over the domain 0 to 1. Now you can apply the Simpson 1/3 rule here. So what is the A? A is my 0, B is my 1. Fine. H, what is the common difference? You can see common difference is my 0.25. So we can find the value of the n. What is the n is? It is my 4, and it means it is not equal to 2. We have to apply the composite Simpson 1/3 rule. So I can start with this value. Since in this case I need a y square, because it's a y square, so this is the value of the y. I can find its square, 0.9896 square, and so on. So I can complete this value as here. So this is my y0, this is my y1, this is y2, this is y3, this is y4. Skip the first and the last part. This is the only even term, rest are my odd terms. So this is the 2 times of, this is my y0, y1, y2, y3, y4. So this is my twice of this and 4 times of the odd terms. I can substitute these values in here, and since it is a pi also, I can return pi on the simplex 1/3 rule here, Simpson 1/3 rule. After the calculation, you can use your calculator, you get this as the right answer. Again, they are talking about the Simpson rule. Find the distance traveled. How you can find the relation between the distance with respect to the speed and time. If I called s is my distance, v is my speed, t is my here. So can you find this as here? Now what is the time period is? 0 to 120. So can you find the value of the s? V of dt over 0 to 120. So this is the distance of this. Now we can apply the Simpson 1/3 rule on here. How? What is my fx? Fx is my v, a is my 0, b is my 120, h, what is the difference between them is, you can see is my 12. So what is the value of the n? B minus a over h. So it is 120 minus 0 over here, so it's a 10, which is not equal to 2. So we can apply the composite Simpson 1/3 rule. I can make a table. Okay, so how you can do? I can make a table of x and y is equal to v, but because v is already there, so there is no need to write the table. So what you can do, this value is my v0, this value is my v1, v2, v3, v4, v5, v6, 8, 9, 10. So I can skip the first part and the last part. 2 times of the even numbers and 4 times of the odd numbers. So I can substitute all the values here. You will get this is the required answer after using the calculator. Look at this another one. Again, this is my fx, a is my here, b is my this. Now you can find h is not given, so you can firstly find the intervals. Take n is any even number. I can choose n is 4, you may choose n is 6, you may choose n is 8, that's on your choice. So if I find here h is mine, so make a table, start from the 0.5 ending at 0.7 with the difference of 0.505. So it is a 0.55, 0.60, 0.65 and 0.7. Now substitute this value. X is 0.5 here, it's a 0.5 e raised to power minus 0.5 you will get here. Similarly for this second value 0.55, 0.55 you will get here. Substitute, you can find it. Now apply the Simpson 1/3 rule. This is my y0, y1, y2, y3, y4. This is the first and the last, you can skip that. This is my even number, so y2 is only even and y1 and y3 are my odd, so 4 times. H is my here, y0 is this. Substitute this value, you will get this is the required answer. Another category is, in this case, is when you are talking about the error. So firstly you can remember this formula. I will give you the proof of the error in our next lecture or in the next video. Till now you can simply remember this. What is the f4 is? f4 is the fourth derivative of the function. H is my b minus a. Whenever you are talking about the modulus sign, so this will give you the maximum value over the x, whatever the domain is given to you, of the f4. I will explain you. Find the interval n, find the value of the h, so that error is within of 10 raised to power minus 5. This is given to you. Fine. And you have to use the composite Simpson rule. The same example we already solved with the help of the trapezoidal rule as well. What is given to you? Fx is 1 over x plus 4, a is my 0, b is my 2, h and n are not given to you. Fine. So what is the value of the h? B my, okay, I can write for you here, h is my this. What is given to you? Error. What is the error of the Simpson 1/3 rule? I can use this formula. So I can write this as here, where h is my this one. I can substitute the value of the h here. What is the b? B is my 2, a is my 0. So you will get here. Now in order to find the fourth derivative, how you can find the fourth derivative? What is the first derivative of this? Minus 1 over x plus 1 whole square. What is the second derivative is? It's a minus plus 2 over x plus 4 cube. What is the third derivative is? Minus 6 over x plus 4 raised to power 4. What is the fourth derivative is? It's a minus 4, it's a plus 24 over raised to power 5. Fine. So my fourth derivative will be here. Now your target is to find the maximum value of this x. What is that? X is 0, 2. X is my 0, 2 of this fourth derivative. Now since it is defined on the closed interval, you firstly check the maximum value is occurring either at the f0 or at the f0 or the values at this, when this value becomes a 0. So this is minus 4, but this value does not lies on this 0, 2. So this is not. Now what is the maximum value of this? Maximum value, if you can see, firstly check whether this function is increasing or decreasing. Clearly says this function is decreasing because it's a 1 over something. It is always with a decreasing. Whenever it's a decreasing, this function is decreasing, so the maximum value is occurring at the lower limit. If the function is increasing, we will see the next example. If the function is increasing, then the maximum value occurring at the upper value. Now since the function is decreasing, so the maximum value of this is occurring at x is equal to 0. So what is the value of this at x is equal to 0? So you can see it's a 0 plus 4 of this. Now substitute all the values at here. what is the value of the e within? So this value is less than of 10 raised to power minus 5. H is my 2 over n, so it's a 2 raised to power 4. What is the 2 raised to power 4? Sorry, it's a 2. Oh yes, b minus a is, I can substitute the value of h, or I can find the value of the h from here. This 2 raised to power 5 180 divided by 2 into 24 raised to power 1 by 4. So I can find this value, which comes to be, if I solve this value by using the calculator, which comes to be here. Now because we need an exact value of the h, but it is not given, I can substitute the value of the h is my here. Now can you find the value of the n? It is greater than of 2 divided by 0.44267. so if you divide them, you will get this answer. Now since it's a Simpson rule, so what is the value of the n? N is always even number. So what is the value of the n even which satisfied this? N is only 6 is the even number which satisfied this number. Now when n is equal to 6, you can substitute here. What is the h? H is my 1 over 3 is the required answer. Look at one more example related to this n and h, and it is given that error is within 10 raised to power minus 4. This is the value of fx. Fine. This is the value of the fx. A is my 0, b is my 2. So this is my here. Fine. Now I can substitute, or what is the h? H is b minus a over n, that is 2 over n. I can substitute here. B minus a is 2, 180, h raised to power 4. Fourth derivative we will compute. So it's a fourth derivative at some point is a less than of 10 raised to power minus 4. Fine. Now we can find the fourth derivative. What is the first derivative? We can apply the product rule. It's a sine of 3x plus 3 times cos of 3x. This is the first derivative. Now we can find the second derivative. What is the second derivative is? Again I can apply the product rule. So it is my 2 times 2 of this sine of 3x plus 3 times of cos 3x plus, for this part 3 is outside, 2 times e raised to power 2x cos of 3x minus 3 times e raised to power 2x sine of 3x. Now I can make the pair. This is a sine, this is a sine. It's a 4, it's a minus 9. 4 minus 9 is here. Similarly, it's a cos and this is a cos. It's a 6, it's a plus 6. It's a plus 12 e raised to power x cos of 3x. This is the f double derivative. Now you can find the third derivative. Similarly, you can find the fourth derivative here. Now how you can find the maximum value? I can start with this modulus value. What is that? This comes to be here. We all knows what is the mod of x plus y. It is always less than equal to mod x plus mod y. So this is less than of 120 e raised to power 2x cos of 3x plus, because minus mod is positive, 119 2x sine 3x. Also we know that the mod of sine x is less than equal to 1, mod of cos x is less than equal to 1. So this number is less than equal to 120 e raised to power 2x. This number is again less than of this e raised to power 2x. So what is that? This number is nothing but 239 e raised to power 2x. Fine. Now since I can return this number here, now your target is to find the maximum value of this function over the domain 0 to 2. Fine. So we have to check firstly whether this is the increasing function or it's a decreasing function. How you can check it's increasing or decreasing? Clearly says exponential part is always with the increasing function. Moreover, if I take g is my 239 e raised to power 2x, what is the derivative of this? 239 of this, which is always greater than 0. If the first derivative is greater than 0, it means this function is my increasing. So once this function is my increasing, what does it mean? Maximum value occurring at the upper bound. So what is the meaning of that? f4, the maximum value is occurring at point of 2. So I can substitute f dash here, value of 2. So what is the value of this? I can substitute here, this is nothing but 239 e raised to power 4, or you can substitute here, that's the same thing. So I can substitute here, I can substitute this value here, you will get this value. What is the h? Is less than or equal to 10 raised to power minus 4, 90, 239 e raised to power 4 raised to power 1 over 4. Now if you solve this, you will get as here. What is the value of the h? I forget to, what is the h is? b minus a over n. b is my 2 minus 0 over n, that is a 2 over n. So 2 over n is less than or equal to 0.0288. What is my n? N is greater than of this number. Fine. Now if you solve them, you will get as 69.4. Since I apply the composite Simpson rule, what is the even number which satisfied this? It is a 70. So once n is my 70, what is the value of the h? H is my 2 over n. So it's a 2 over 70 is the required answers for the n and h. So it's the equality, it's my here. If you want to calculate this, n is my proper 70, h is my 2 over 70 is the required answer. This is the way you can solve this Simpson 1/3 rule. We will see the next lecture on the composite error analysis of the Simpson 1/3 rule. Till now, you can simply like, share and comment on my video. Best of luck students. Happy learning.